Hello everyone, and welcome to this video on rationalizing a denominator containing two terms. So in this video, I'm going to go over several examples in which we're asked to rationalize the denominator, and the denominator will have two terms, and the expression in the denominator will also contain a radical or multiple radicals, square roots. And we're only going to go up to square roots today, no cube roots, because it gets more complicated. And this is really just for the intermediate or beginning algebra student out there. Alright, so let's begin. So this first example, and every example in this video, I have the following instruction. Rationalize the denominator. And if you recall, my last video I put up was also on rationalizing denominators, but where the denominator had one term. And what they mean by rationalize the denominator is to rewrite this expression as an equivalent expression without a radical in the denominator, right? So that you have a rational number in the denominator. Okay, so notice that this denominator does have two terms, right? There's the square root of 3 plus and then the 1, right? So a little different than last video where everything had one term in the denominator. So here's the incorrect way of going about this, and I'm only putting this up because I see this mistake made very often when the denominator has two terms with a radical and people try to rationalize it. So we have 4 divided by the square root of 3 plus 1. Right. Very often I'll see people doing this. They see the square root of 3 in the denominator and they remember what it was like to rationalize a denominator when it only had one term, right? If this was the only term, or say I got rid of this plus 1 here, right? If that were the only term in the denominator, all I would need to do to rationalize would be to multiply the numerator and denominator by the square root of 3. So people tend to remember that. They're like, hey, if this was by itself down here, I would multiply the numerator and denominator by the square root of 3. So let me do that now. Multiply the denominator by the square root of 3 and multiply the numerator by the square root of 3. But notice how I put parentheses around this, right? This has multiple terms, this denominator. So when you do this, remember how to, when you multiply a two-term expression by a single-term expression, you would have to distribute this square root of 3 to both terms. So hopefully you can see now that the denominator would not be rationalized. Let's look. All right, the numerator would have 4 times the square root of 3. All right, so 4 times the square root of 3 divided by, right, in the denominator, we'd have to distribute, again, multiple terms here. Square root of 3 times square root of 3 would be the square root of 9, using the product property, which is 3. Great. So that radical is gone now, right? Wonderful. That's what we're trying to do. But we're also adding to that the square root of 3 times 1. And that would just be the square root of 3, and, uh-oh, right? I mean, what I did wasn't wrong in the fact that, this number is still equal to this number, right? Because you would just multiply the top and bottom by the same thing. But it's not what we're being asked to do. The denominator is not, rationalized. Because you still have this radical down here. All right, so be very careful. Right. You can't treat these expressions with two terms in the denominator like you did when there was only one term in the denominator, which is over here, right? Ends up being wrong, or ends up being, again, an equivalent number. It's still the same value, but just not rationalized denominator. All right, so what do? Well, with these, two-term expressions with square roots, we have to make use of this fact here. So do you recall from, I've had this up in previous videos, multiplying conjugates. multiplying what are called conjugates. If you multiply two pairs of conjugates, right, the conjugates are these. One term, one factor is, say a plus b, and multiply by another factor. The conjugate of a plus b would be a minus b. So basically they're the same thing with just a different sign in the middle. All right, these here would be considered conjugate pairs, right? A plus b and a minus b. And if you recall, when you multiply two conjugates, you end up with a difference of two squares. If you were to distribute the a and then distribute the b and combine like terms, you'd end up with the a squared minus the b squared, right? You end up with a difference of two squares. So we have to keep this in mind right here. Right? This is going to be huge for us when we're rationalizing a denominator with a square root and two terms like this has. All right. So here I have 4 in the numerator divided by, again, the square root of 3 plus 1 in the denominator. And what we're going to do to rewrite this so that there's no more radical in the denominator, no more square root in the denominator, is use this fact. So what is the conjugate of the square root of 3 plus 1? It would be the square root of 3 minus 1. Again, the same two terms basically, just with a different sign on the second term. So that multiplication that we're doing, I'm going to multiply, again, the numerator and denominator by the same thing, so it's like I'm multiplying by 1 and not actually changing the value of the expression. Now the numerator has just one term, so no need for parentheses around it. I'm going to multiply that by, the quantity, the square root of 3 minus 1. Right? This is the conjugate of the square root of 3 plus 1. And the same for the denominator. Now this has two terms, right? So I put in parentheses. We're multiplying this whole thing, both these terms, by this whole thing, its conjugate, the square root of 3 minus 1. Right? Okay, so we multiply the numerator and denominator by the conjugate of the denominator. And look at what happens. In the numerator, right, now you have a one term, 4, multiplied by a two term expression. So this will require distributing, right, when you multiply. So we have 4 times the square root of 3, right, which is just that, 4 times the square root of 3. Can't put those together because they're not both square roots. You can't use the product property there. And then 4 times the negative 1 be negative 4. Okay, so the numerator looks like that. And the I guess I could have kept it factored. I probably should have. We'll see in a second why. Then the denominator. Think about these conjugates. Now you can do the whole distributing thing. Distribute the square root of 3 to this over here, these two terms, and then distribute the 1 and combine like terms. But really, if you want to think about this as, this is a plus b, where the a is the square root of 3 and the b is 1, and this is times, a minus b, where again, a is the square root of 3, b is the 1. So this will end up being a squared. Well, what's the square root of 3, times the square root of 3? That's just 3, right? The square root of 9, when you use the product property, which is 3. And then minus, and then what's b squared? 1 times 1, or 1. And look at the denominator now. Right? After multiplying these conjugates, you end up getting rid of the square root symbol, right? There's no more radical. This is rationalized. But the fraction itself isn't simplified, right? So let's do that. All right, so I know what I'm going to do, because I'm trying to, simplify a fraction. Right? Remember, when you simplify a fraction, you factor the numerator, factor the denominator, and then cancel any common factors that the numerator and denominator have. So I'm going to rewrite this again. The numerator. Notice how the numerator has this common factor of 4. I'm just going to write it the way it was up here. pull that 4 out, times, and then you have the square root of 3 minus 1 left over when you remove a 4, right? So I'm just writing it the way it was up here, divided by, and the denominator is 3 minus 1, or just 2. And hopefully you can see that there's a common factor in this numerator and denominator, right? And that common factor is 2, right? 4 is 2 times 2. So there's a 2 and 2, and then this factor of square root of 3 minus 1, but I'm not seeing that factor down here. But there's a factor of 2 here, right? So 2 in the denominator, and then when you get rid of a factor of 2 here, you'd be left with still a factor of 2, right? 4 is 2 times 2. Alright, so when all's said and done here, I'm left with, in the numerator, a factor of 2 times the other factor, the quantity, the square root of 3 minus 1, and then divided by, and then this would become a 1 down here, right? There's only 2, that's 2 times 1. I got rid of the factor of 2. So I mean, this is good. This is totally simplified, right? The numerator and denominator don't have a common factor, and there's no radicals in the denominator, so it's considered rationalized. But I think most texts that you see in either intermediate or beginning algebra especially will appreciate that you don't have parentheses at the end. Okay, so this is fine, this is great. I'll put in a little bubble, but you can distribute the 2 as well, get rid of the parentheses, use the distributive property. So this is equal to 2 times the square root of 3, alright, 2 times the square root of 3, and then minus 2 times 1, right, minus 2. Great, and then these don't go together, right? One has a radical, one does not. These are not like radicals. You cannot put these together. That would be as simple as it gets. Wonderful. Now, you know me. Right? I like to make sure that the number I ended with is exactly the same as the number I started with. Right? They should be equal. So I'm going to go to the calculator, and we'll punch these expressions in and see if they indeed are representing the same number. Alright, so here I have numerator of 4 divided by, and the denominator has multiple terms. And when a numerator or denominator has multiple terms or even multiple factors, I like to put it all in parentheses, right? So divided by, and then in parentheses, right, this entire thing in parentheses is going to be the denominator, the square root of 3, and then plus 1, right, close parentheses, there's the whole denominator. Alright, and that's the number 1.464101615, and so on and so on. Alright, so hopefully, after all this, multiplying the numerator and denominator by the conjugate of the denominator and simplifying, this number I got in the box here is exactly the same. So let's see, this expression is 2 times the square root of 3 and then minus 2. And notice how that was a lot easier to type than the first expression. It is simpler. And look, yes, indeed, it is the same number, 1.46101615, and so on. Great, that's what we want. Alright, so I just got a couple more of these. So I'm doing the exact same thing each time. I'll have a denominator with a square root in it, or maybe 2 square roots, but 2 terms. And then we'll have to multiply by the conjugate to be able to rationalize. Okay, so my next example, I'm asked to do the same thing. I want to rationalize the denominator. It is definitely not right now. I actually have 2 terms with 2 radicals, two radical symbols in the denominator. I want none. All right, so I'll write it the way it is. We have the square root of 2. This is getting kind of faint. So I have the square root of 2 in the numerator, divided by, and then again, I like to put, if it has multiple terms, the parentheses around it, the square root of 6 minus the square root of 2, in the denominator. Right? This is just how I would enter it in the calculator. And we're going to rationalize. Now, don't just multiply by the square root of 6 in the numerator or denominator, or don't just multiply by the square root of 2. Right? This is a denominator here with 2 terms. So in those cases, when you have 2 terms and a radical, a square root, and this is again for square roots only, we're going to multiply by the conjugate of the denominator. Now this is the square root of 6 minus the square root of 2. The conjugate would be the quantity the square root of 6 plus the square root of 2. Alright, and if I'm doing that to the denominator, I'm going to again also do that to the numerator. Alright, so that way it's like I'm multiplying by 1 and not actually changing the value. Alright, so in the numerator, I have a single term multiplied by two terms. There's going to be distributing going on here, and a couple uses of that product property because they're all square roots. So I have the square root of 2 times the square root of 6. That's the square root of 12, right? I can put them together with that. They're both square roots of non-negative numbers. They're both real, so I can use that product property. The square root of 2 times 6, or the square root of 12. Then plus, and then the square root of 2 times the square root of 2. That's the square root of 2 times 2, or 4, and I will simplify these radicals in a second. Right? They are able to be simplified. There are perfect squares that go into 12 and of course 4 evenly. So that's the numerator. And then the denominator is that multiplying two conjugates. So I'll end up with a difference of squares. The square root of 6 times the square root of 6, or just 6, or the square root of 36, minus the square root of 2 times the square root of 2, that's just 2, right? The square root of 4. I know I didn't write it up there, but I am right down here. This is what you would end up with. Now you could do the whole foiling thing or just all the distributing and say, oh, I got the square root of 36 plus the square root of 12 and then minus the square root of 12. So then the square root of 12 would go away and then minus the square root of 4 and end up with 6 minus 2 anyway. Alright, so now, okay, the denominator is now rationalized. Alright, there's no more radical down here, no more radical symbol. But this, I need to simplify this, right? So let's simplify the radicals. Now the square root of 12, I've put up videos before on simplifying radicals, so I'm not going to go into all this too deeply. The square root of 12, right, you can break that apart to the square root of 4 times the square root of 3, and the square root of 4 is 2. So the square root of 12 simplifies to 2 times the square root of 3. Right, that is the square root of 12 simplified. Plus, and then the square root of 4, is simply 2. And then all this in the numerator divided by, and the denominator is simply, 6 minus 2. That's 4. Alright, and then again we want to simplify the fraction. In order to simplify a fraction, you factor the numerator, factor the denominator, and cancel any common factors. The numerator has two terms. Hopefully you can see that each term has a factor of 2 in it. So I can pull that out, factor that out. And if I remove the factor of 2, what's left is the square root of 3 in that first term, plus, and then 1, right? 2 times 1 is 2 in the second term. So I have 2 times the quantity, square root of 3 plus 1 in the numerator, those two factors, divided by, and then 4 is, 2 times 2, or 2 squared, or you could have left it as 4 as well, but I wanted to write it as 2 times 2 so we can easily see the canceling that's going to go on the division here. We've got a factor of 2 in the numerator and a factor of 2 in the denominator. Those divide out to be 1. All right, technically, again, they become 1. Anything divided by itself is 1. And I am now left with the following fraction that is totally simplified. In the numerator, I have only really one factor left. That's this square root of 3 plus 1. And since it is the only factor left, no need for the parentheses around it. Divided by, and then the only factor left in the denominator is the number 2. Alright, so there is a totally simplified fraction. The numerator and denominator don't have any common factors. And you can now see the denominator is rationalized, right? There's no radical. And you could also write this another way, right? Remember when the numerator has multiple terms, you can split up and divide each term in the numerator by the denominator, right? It's just like reversing adding fractions. So I can write this as the square root of 3 divided by 2, right? Just make sure the division sign is outside the radical, right? It's outside. So that's the first term divided by 2, then plus, and then the next term 1 divided by 2. Right, divide each term in the numerator by the denominator. And this would be the same thing as well. Right, they're the same. You can go back and forth. Right. And can you see how, remember when you add or subtract, you need a common denominator, and that denominator stays throughout. So if I were to say add these two, this is the fraction you'd get, right? You'd keep the denominator of 2 and then combine the numerators, get the numerator of the square root of 3 plus 1. All right, great. Let's check it. So I'm going to go back now and just get rid of all that. We said that this number here, the number I started with, is equal to this. Or this, right? Whichever one you want to put. Let's see. They should be, right? If I did everything correctly, they should have the same value. This expression here, the numerator, is the square root of 2 divided by, and then the denominator has multiple terms, right? So the way I'm going to enter this is put parentheses around this entire denominator. So in parentheses, the square root of 6, then after that minus the square root of 2, and this number that we started with is 1.366025404 dot 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 dot. All right, it keeps going, I'm sure. All right, hopefully this value I got in the box here, this last fraction with the rationalized denominator, has the same value. So I'll punch this in. All right, now the numerator again has multiple terms. Anytime something has multiple terms or multiple factors, I typically like to put it in parentheses. We're doing this whole numerator divided by 2. So the square root of in parentheses, the square root of 3, then afterwards plus 1, close parentheses, that's the numerator divided by 2. And hopefully I'm getting this 1.366 again, and I am. Great. And like I said, you could have also split it up, divided each term by 2, and written, the square root of 3 divided by 2, and then plus 1 divided by 2, and see it's the same exact thing. 1.366 and so on. All right. Great. All right, so I have one final example where, so far, these examples, the numerator has had one term, so I just did a simple distributing when I multiplied the numerator and denominator by the conjugate of the denominator. All right, in my last example, my numerator has 2 terms. All right. So the denominator and the numerator both have 2 terms here. And we're asked to do the same thing. We're asked to rationalize the denominator. Right? So I want to rewrite the denominator so it doesn't have these radical symbols anymore. It doesn't have these square roots. All right, so again, I'm going to rewrite this. I'm going to write it the way I would enter it in my calculator. Numerator has multiple terms, so I'm going to put that in parentheses. It's the square root of 5, then plus 4, and then that whole thing's the numerator. Divided by, and denominator again has multiple terms, so if I were entering this in a calculator, I'd put that in parentheses as well, the square root of 5 minus the square root of 2. And I wish to rationalize the denominator, right? Get rid of those square roots down there. Again, you can't just multiply by the square root of 5, and you can't just multiply by the square root of 2. We must, with these 2 term expressions with square roots, you must multiply by the conjugate of that expression. All right, so I'm going to multiply the numerator and denominator by the conjugate, putting them in parentheses because they'll have multiple terms, 2 terms. The conjugate of the square root of 5 minus the square root of 2, right, that would be the square root of 5 plus the square root of 2. Right? And then same thing to the numerator. I multiply the numerator also by the square root of 5 plus the square root of 2. All right. So the numerator, see, is a bit trickier this time because I have a two-term expression multiplied by a two-term expression in the numerator. But remember how that works. You do it like you did polynomials. Pick one of them, right? So say I pick this one here, right, the square root of 5 plus 4, and then take every term from this one, distribute it to the other one, and then combine like terms and simplify, and combine like radicals at the end. So I'm going to start with the square root of 5. And we'll distribute that to this square root of 5 plus the square root of 2. So in the numerator I have, the square root of 5 times the square root of 5, that's the square root of 25. Right, those are both real, so I can put them together like that with the product property. And then I have the next term, I have square root of 5 times positive square root of 2. So that'll be positive 2. I can use the product property again because they're both square roots. That's the square root of 10, right? 5 times 2. Alright, now I'm done with the square root of 5. I'm going to move over to the positive 4 and do the same thing. Distribute the positive 4 to those terms. Alright, so positive 4 times positive square root of 5, that'd be positive plus, and then you can't put these together. That's not the square root of 20, right? Because this is not a square root. Right? So this is not in the square root, this is a square root. So you just write them as is, right? 4 times the square root of 5, like that. And then positive 4 times positive square root of 2, that'd be positive, and then again, one's a square root, one is not, so you just write the factors as is, 4 times the square root of 2. Alright, so here is the numerator, and we'll simplify some of this later. Alright, well, really there's only one radical up there that we can simplify, and that's the square root of 25. Alright, now the denominator. Again, when you have the a minus b times a plus b, where here the a is the square root of 5 and the b is the square root of 2, you end up with when you multiply conjugates like this, you end up with a difference of squares. The square root of 5 times the square root of 5. Square root of 5 squared would just be 5. Then minus, and then the b squared would be the square root of 2 squared. That'd be the square root of 4, or 2. And you see how the denominator is rationalized now. Okay, now let's actually simplify the thing. All right. Simplify the radicals. Now in the numerator, the square root of 25 is 5. Plus, now the square root of 10, can't do anything with that, right? There's no perfect square that goes into 10 evenly other than 1. So that's as simple as that gets. Same thing for the square root of 5 and the square root of 2, right? There are no perfect squares other than 1 that go into 5 or 2 evenly. So these are also the way they are, right? Plus 4 times the square root of 5 plus 4 times the square root of 2. Right? And none of these are like. None of these are like radicals. None of these are like terms. I cannot combine any of these. This is the way the numerator would have to stay. So all of that is the numerator. That thing with 4 terms. 5 plus the square root of 10 plus 4 times the square root of 5 plus 4 times the square root of 2. The denominator is easy though, right? You got 5 minus 2. You can combine those. Those are constants, like terms. And that's simply 3. And there's nothing to factor out. And, look at all the terms in the numerator. They don't all have some common factor that I can pull out. So that's as factored as it gets, and I am not seeing that same number down here to cancel out. So this is it. This big fraction I got here is the final result. Now you could write it that way, or as I did in the last example, this numerator has multiple terms. You can divide each term in the numerator by the denominator and get an equivalent number, right? So you can take this and write it as 5 divided by 3, or 5/3, then plus, and then the square root of 10 divided by 3, and again, please make the division sign big enough so you know it's not inside the square root. Then plus, and then 4 times the square root of 5 divided by 3, Or you could write 4/3 times the square root of 5. Same thing. This is the same as 1/3 times the square root of 10. And then plus, and then 4 times the square root of 2 divided by 3. Or 4/3 times the square root of 2. This would be fine as well. And just, bunch of fractions. Alright, and let's just, again, I know it looks weird. It's pretty big and crazy, but let's see if it is the same as the original value after all that multiplying by the conjugate and distributing and simplifying and all that. Okay, so let's test it out. So on my calculator, in the numerator, again, this has multiple terms, so I'm going to put that in parentheses. We have the square root of 5, then plus 4, close the parentheses, that's all the numerator, divided by, and then the denominator again has multiple terms, so I'm going to put that in parentheses as well, the square root of 5, and then after that minus the square root of 2, and then close the parentheses. There's the whole denominator. Alright, so this number is 7.587801273. Now hopefully, if I did everything correctly, what I got in the box here should be the same number. So in parentheses, right, the numerator definitely has multiple terms. It's got 4 terms. So in parentheses, I put the numerator 5 plus the square root of 10 plus 4 times the square root of 5. After that, plus 4 times the square root of 2. Close parentheses. There's the numerator. And then all of that divided by just 3. Right? There's no need for parentheses around that. It's just a single number. And look at that. It is indeed the same value. And it has, a rationalized denominator like they asked for, right? A denominator without a radical, without a square root. Great. All right, so the key to take away from this today is that if you're trying to rationalize, if you're being asked to rationalize a denominator with square roots and 2 terms, you must multiply the numerator and denominator by the conjugate of those 2 terms, the conjugate pair. Then you'll end up with a difference of squares, and you'll get rid of that. You'll get rid of those radicals, those square roots in the denominator. Pardon me. Great. And as I like to say at the end of these videos, try the best you can to learn the material on your own before you go looking for help. I find that when people take the time and the effort to learn something on their own, they tend to remember it better and for longer. They're more proud of it. So, read the material, of course. Read through the author's examples. Perhaps even try to work out the solutions to some of the author's examples before you see how the author did it. And then, compare your work with the author's. See if you can learn from some mistakes there. Obviously, work on tons of examples, practice problems, exercises, and look up solutions to those if they're made available, so you can check yourself and see how you're doing, track your progress. And don't just give up on a problem after one or 2 attempts. Don't give up so easily. Very often in mathematics, several different approaches will work for any particular problem. So if after several attempts at a problem you're still not getting how to do it, still not seeing it, perhaps you should read through the material again, maybe even a 3rd time, more slowly, more deliberately, take good notes. Because if you've been working on some problems, chances are you have a better idea as to what the author is asking you for, what the author wants from you. So then that'll give you a better idea as to what to look out for the next time you read the material, or the 3rd time you read the material. And you'll probably see some things, or things will make sense that didn't the first time, and it'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at the problems, you're still not getting it, well, then it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's tons of them out there. Look for videos online. There's tons of those too. Videos like this one, or other ones out there that are better than mine. I assure you they're out there and they're easy to find. Just keep at it is all I'm saying. Stay persistent, keep practicing, don't give up. And I think above all, the hardest thing is to believe in yourself. Have a positive attitude about the subject. And just don't get too down, don't get too discouraged when you're struggling, when you're failing at things, because that's the best time to learn. Is when you struggle and when you're failing. You learn from your mistakes. It's where most learning is done, is after a failure. So just stay persistent, keep practicing, try to stay positive, please. Right? It's amazing the difference a positive attitude can make in the learning experience. And just don't give up. And I'm sure you'll eventually get it. All right. Thank you very much for watching.